So we are going to find the approximate integral of f of x is equal to x squared from x is equal to 1 up to x is equal to 3 using n is equal to 6 ordinate. So we are using the number of ordinates equal to 6. So let us look at the solution. Now, if we have 6, if n is the number of ordinates, okay, if n is the number of ordinates in this scenario, then number of sub-intervals, okay, number of sub-intervals is going to be n minus 1. Make sure that you note this one very well. If n is the number of ordinates, then the number of sub-intervals are going to be n minus 1. Therefore, in this scenario, number of sub-intervals is going to be 6 minus 1, which gives us 5 sub-intervals. So if it gives us 5 sub-intervals, what is h? So h, which is the width of each sub-interval, so h is equal to always b minus a out of n. So out of n minus 1 if we are talking about sub-intervals. So this is going to be 3 minus 1 out of 5. And this is 2 out of 5. And this is supposed to be 0.4. So I've gotten our width of each sub-interval as 0.4. And it's time to do the calculation. So we will have x and we will have f of x, which is x squared. So if it starts from 1, okay, and there is a step size of 0.4, so it is going to be, it is going to go to 1.4, 1.8, then this is going to be 2.2, okay, 2.2, 2.6, and finally 3.0. Now, our task is to look for, first of all, f of x naught. So f of x naught is going to be f of 1, and also find for, we calculate for f of xn. F of xn, which is the same as f of 3. Okay, yes. So let's do that. We are going to put 1 in x squared, and that becomes 1. Then we also substitute in f of x, where x is, we put there 3. So that will be 3 squared, which gives you 9. So we start now putting 1.4 squared. What will that be? This gives us 1.96. Then 1.8 squared, we get 3.24. Then 2.2 squared, we get 4.84. Then 2.6 squared, we get 6.76. And that's all. Then we sum. So we sum these values, okay, because these are intermediates. So we have f of xi and f of xn and f of x naught. Okay, so what we do, we sum f of xi, and this is going to give us 1.96 plus 3.24 plus 4.84 plus 6.76, and this gives us what? This gives us this is giving us 16.8, and if we sum f of xn, okay, plus f of x naught, this is giving us what? This is giving us 9 plus 1, and that is 10. So what does that tell us? That integral of x squared from 1 to 3 with respect approximates to what? to 0.4 out of 2 into, we have already said we have 1, okay, plus 9, then plus 2 into the intermediate points, which is 16.8, and that's all. So this is going to be 0.2 into 10 plus 16.8. If we multiply by 2, we get 33.6. So if we add 10, okay, and we multiply by 0.2, this is giving us 8.72. So if we do direct integration, so from direct integration gives us integral from 1/3 of x squared dx, or with respect to x, gives us x cubed out of 3. So we put 1 to 3. So this is 27 out of 3, okay, minus 1 out of 3. And this is 28, 26 out of 3. So 26 out of 3 gives us, so it tells us that we have integral of x cubed with respect to x from 1 to 3 equal to 26 out of 3, which approximates to 8.67. So what is the error? The error in this is going to be 8.67 minus 8.72 divided by 8.67. We multiply by, so 8.72 minus 8.67 divided by 8.67. So multiply by 100. The value, the error in terms of percentage error is 0.58%. So since this is also small, you can neglect it. But in some fields like electrical or electronics, this can be a very big error, and therefore it may not be neglected. So depending on the field of application, you can neglect this error being too small.